Hello, everybody. Welcome back to a new midnight session. Let's get started. We're gonna talk now about the one of our ecosystem partners. We have already talked about Lace, but let's talk again about Lace because they have something new coming. So let's take a look at the Twitter post. I saw it yesterday. They're saying, reminder, Lace AMA this Thursday, June 12th. We're diving into Lace. It's a new version 1.24, and they're going to be talking about possible a full Midnight support, right? As we know, they're already building this Midnight Lace wallet, and they have the Cardano Lace wallet. They're going to integrate Bitcoin DeFi, and now they might be integrating the Midnight part into the Cardano part. So let's see what they're going to talk about it on Thursday. And also they're going to be talking about the Glacier drop. So yeah, that's a AMM that for sure I'm not going to miss. Perfect. Now let's see what is a new block that just dropped. This one is really interesting. It's regarding the some summary that conversation that happened during the consensus 2025, right? And let's take a look at some topics. They discuss about breaking free. So this is a concept that boils down to programmable privacy, right? So let's see what they mention about it. Here it says full visibility in widely adopted systems open the door to surveillance and control. So other blockchains, as for example Monero and Zcash, there is just full privacy. You cannot disclose information. But actually, for building applications that solves real issues of businesses, you actually need this programmability within the privacy part. So that's where this break free is coming along, connecting blockchain with actual businesses. They mention the launch of two organizations, the Midnight Foundation and the Shielded Technologies. And they are mentioning here what is the purpose of each business, right? The Midnight Foundation exists to guide the long-term direction of the network, support ecosystem development, and engage the Night community. So everything about community, long-term vision of Midnight as a network. And the Shielded Technology, it's focused on delivering the protocol, building out the core infrastructure, creating tools for developers, and advancing the technical roadmap. So these two entities is gonna shape what is the Midnight ecosystem along with the community itself. As we see in Cardano, community takes a huge part of the ecosystem, and that's something that Midnight Foundation wants to build as well. So this is really good news. They talk about this concept of rational privacy, which is this is a phrase that I love it. Privacy doesn't need to be absolute or opaque. It needs to be programmable. So yeah, I love that concept, and actually it boils down to what Midnight actually does, right? They mention about cooperative tokenomics. That's another huge topic, and this is something that maybe, not sure, the Lace team are gonna talk about the Glacier drop. So the Glacier drop involves a lot of topics, right? They haven't been disclosed yet. So, but at the end, we can see that it should be something related to cooperative tokenomics. So here what they're saying. The philosophy is embedded in Midnight's architecture, and it's designed with interoperability at its core. So let's take a look here. The future of blockchain isn't competitive, it's collaborative. So as we're gonna see in Midnight, we're gonna want to integrate different blockchains, and you're gonna be able to use Midnight as an L1, but actually as a sidechain or as an API without having to use Knights themselves. You can use whatever native tokens of your blockchain and just use some features of Midnight. So Midnight is going to actually melt faces with what they want to integrate. And I'm just bullish on these new features that are coming in. It's built for builders. So that's something that we've seen so far, right? We are improving along the way. It's regarding the user experience and developer experience. Midnight, they've developed the compact DSL. So actually, you don't need to understand the intricacies of cryptography and how to stick together all these cryptography libraries. You just write your logic using compact, and then it compiles to JavaScript, where you actually can integrate in other frameworks. So this is a really nice developer experience. They are developing the midnight.js SDK as well. So you can talk with the different instances and providers. And at the end, what they want is to open the ecosystem, right? So far, every blockchain's been working in silos. They don't have motivation to collaborate with other blockchains, since they just want more people to come into their blockchain, so people buy their tokens. The way Midnight is being built, it's to promote this broader ecosystem to collaborate, right? So big news, and I love the vision and the strategy that Midnight is taking. Okay, let's go to the education part. It's gonna be 8 modules. Let's take a look here. For those that haven't seen the Academy section of Midnight, they're gonna create 8 modules regarding education for the Academy section. So far, there is 5 modules available, and we are going through the first module. So in the first module, we have already studied what is the history of blockchains, some core concepts about decentralization, consensus mechanism, nodes, and now we're going to talk about tokenomics, which is a huge topic. I've made a summary of these important topics about tokenomics, and we're going to cover 4 main areas: utility of tokens, tokens as incentives, tokens for governance, and what it means a token to be inflationary or deflationary. So regarding to utility, one of the main purpose of a token is to actually serve as the currency of the blockchain itself, where you pay that token for executing a transaction or for actually using a smart contract. Another component of tokens is incentives, where, for example, in proof of stake, the SPOs receive tokens for participating on creating blocks, and users receive part of those tokens for having a stake. For example, their Edda, in the future is going to be Nights for Midnight. So you are incentivized to collaborate within the network. Then for governance, we've seen in Cardano, we now have this governance framework, and with Edda, you are able to actually express your intentions and vote on things. In Midnight, we're gonna have a governance framework and process as well. And then we have 2 concepts that we've seen regarding tokenomics. We can have inflationary and deflationary. Inflationary, let's say more tokens can be issued by when you are staking or doing something on the blockchain. For example, Ethereum, they create tokens, right? And deflationary, we can see Bitcoin and Cardano. We have a fixed amount of tokens, and there is that cap. We cannot go beyond that. Okay. Now let's do some refresh about the hackathons and share some, give some awareness about some topics and going through the deadlines, just to make sure that nobody misses the deadlines, right? So we have those topics that we mentioned, right, regarding the categories. And then we want to have the judging criteria. The judging is divided in 4 for the first 4 categories, which is impact, reusability, quality, and adoption potential. And for the NFT, we have these other 4: creativity, technical execution, which is regarding the artwork clean, is the artwork clean, professional, and well formatted. Then we have a relevance to Midnight and the impact. The deadlines, let's see if we can find here. The deadlines for the registration process, it's on June 13. So you just have 3 days for registering. So don't miss that deadline, okay? For registering, you just go here to the top and you can register, right? Okay, so now let's go down to the code, right? To learn, at the end, we want to learn how to build smart contracts and create end-to-end DApp applications. So now let's open our favorite IDE. In this case, now I'm testing Windsurf. So now we were going through some APIs, right? Now we're gonna keep learning those other functions, really important, built under this API file, which is join contract and deploy, right? These 2 functions are important functions because they abstract all complexities regarding how to do certain actions within the blockchain of Midnight. So let's see how we built those functions. Join contract, we're going to create an async function where we're going to pass 2 arguments. One, it's the providers of type counter providers. We have already learned how to build those providers and what those providers are. And then we're going to pass the contract address of type string. And this is going to give us this type, which is a deploy counter contract. We have declared that type on the common types file. Again, if you haven't heard about these concepts, I recommend you guys to go through the last sessions where we explain how to create those types. And now let's create that function. We're going to use this method, this function, which is called find deploy contracts. Where this function is coming from? If we go at the top, we can see that we are importing that function from the midnight.js contracts library. So, as I mentioned, midnight.js is creating this SDK where we have some functions on it. John, we're going to open for questions after 20 minutes. So you can ask your questions in that moment. Right now, we are just giving a summary for everybody, and then we're going to respond some questions. Okay, so this function comes from the midnight.js contracts. So now we call it, and this function, we're going to pass the providers, and then we're going to specify an object. How this object has to be structured. First, we're going to pass the contract address, and we're going to pass the instance of our contract. And that instance, we created it the last session, which is the contract, which is the class that we got by compiling our contract and passing the witness. So in that way, we get our instance. So we pass the instance of the contract, and then we're going to pass the ID of our private state. In this case, we have declared a ID called counter private state. So this is where our private information is going to be stored in our machines. And then I declare an initial state of our private state. So the state is going to be stored under this ID, and the value of our private information is going to be 0, private counter 0, right? Perfect. And then I return the counter contract. So this is the way to create a deploy contract abstraction. And this output is going to have some methods. We're going to take a look at that in a bit. And following the same procedure, we can actually create a function not to join a contract, but to actually deploy a contract. So again, we're going to pass these two arguments, which is providers and private state, having the same types as declared before here in the join contract function. And as output, we're going to have a deploy counter contract as well. So the output for joining a contract or deploying a contract, it's actually a contract. In this case, we, instead of using find deploy contract, we're going to use deploy contract. And this function is coming from the midnight.js library as well. So we can see we're using midnight.js contracts library, where we get the find deploy contract and the deploy contract. So now we call the deploy contract and we pass the arguments, the providers, and another object. In this object, if we compare from the previous object, from the join contract function, we can see that in this case, this object, it only has 3 properties, and this one has 4. So in the deploy contract, we can see that we don't provide a contract address, because actually by deploying a contract, you're going to create a new contract address. So in deploy contract, you just pass these 3, the contract instance, your private ID, your instance of your private ID, and the actual private information. And when you are joining the contract, besides these 3 properties, you're going to have to pass the address of the contract that you want to join. Excellent. So now that we have these 2 functions, we can create a new function that actually executes a circuit, right? Just remembering some important concepts. Using compact, a DSL, we define what are the ledger variables, and we define some circuits. So these circuits, it's what I'm talking about here on the API. I want to execute a circuit called increment that was defined on the compact side as increment, right? So now I want to execute this. So I have joined or I have deployed a contract, and now I want to execute that circuit increment. So the way to do that, it's by creating this function. So let's see. I'm going to create an asynchronous function where I'm going to pass a counter contract. What is this counter contract? It has type deploy counter contract. So if we remember, these functions, deploy and join, they actually create an output of type deploy counter contract, which is the input for this new function, the increment function. So perfect. This output is going to be the input for this function. And the promise is going to be a finalized transaction data. We're going to take a look at that output in a bit. So now we call this output, which is now the input of increment counter contract, which is after running these deploy or join contract functions. And let's take a look at what methods we have available on this object. We can see that we can call a circuit, which is under a method called transaction. And then we have other 3 methods. One is deploy transaction data, where we're going to be able to see all the data that was deployed during the deployment of the contract. And we're going to have other 2 methods that are going to be really important in the future. And we're going to go through those methods to understand how Midnight offers some capabilities that other blockchains would require the developer to perform some certain actions that involves a lot of procedures and nightmares, which is circuit maintenance and contract maintenance. Really nice topics, but we're going to discuss about that in later sessions. So now we're going to focus on this method called transaction. So with call transaction, we are going to be able to execute the circuit. So we call that method call. And after calling call transaction, we can see that we have other methods. In this case, just increment. If our contract had other circuits, we would see here that in these call transactions, all these circuits would be listed. And we can choose whatever circuit we want to implement. In this case, our only circuit, it's called increment. So we call it increment. And then we have to pass the arguments necessary to run the increment function. If we see the compact code, we can see that the increment circuit, it doesn't have any arguments. So we don't need to pass any. So in this case, we call increment and we just declare it as an empty function. So after calling this function, magically, and this was worked by the Midnight team, the SDK of midnight.js, they abstract all the complexities of how to talk with the different providers, how to execute different workflows to actually send information to the blockchain, how to update the indexer and receive the information back. Everything, all that process, it's boiled down to this function. So it's a lot of abstraction, and it's a really nice developer experience. So with this, we are executing our circuit, actually running our first smart contract end to end. And the result of that, we have this finalized transaction data. So this finalized transaction data actually will receive all type of information. What kind of information? I have listed here the output using the logger function. So I have already run the circuit, and I'm displaying this output, which is here, right? So here we're gonna see what it means, each of these topics. For example, public transcript. What it's, for example, fallible effects, guarantee effects, claim expense, claim receives, claim nullifiers. So for understanding those concepts, in the next session, we're going to go through some schematics to actually understand how data is stored on the blockchain for CSwap, for Kashina, how the state is stored in our machines, and how all these different stakes to talk to each other, and actually how they are stored on the blockchain itself as commitments. So we're going to see all that in the next session. And well, now I'm just going to open I'm going to open the mics to answer any questions or discuss any topics that you guys might want. So I'm opening the mix. Okay, mics are open. Welcome everybody. And well, you can just go ahead and ask me anything.
Hey, Eric, I want to ask you how you are doing.
Hey, Caleb. Thank you. Yeah, I'm doing okay.
Yeah, it was a nice presentation.
Thank you.
I was integration like a starter template. I was also looking at this and I was experimenting with the CLI. And I was wondering like something very convenient like the CLI, but for the dApp. Yeah. Oh, you have Counter UI. Is there a way you can share it?
Yeah, Caleb, all this material, it's open source, right? So what we want to do here, it's actually integrate the contract part, the logic part, and the UI part. And this is going to be all available. So let me explain what we are doing here specifically, right? In this starter template. This is something that we are building on Mesh, building on top of the examples being developed by the Midnight core team. So as you can see, we have these three folders: the contract, counter CLI, and the counter UI folder, right? So let's open the repo to just to give you an example how we are building this. So here in the repo, let's find the repository of Midnight. You can see here that Midnight is building this repo called example counter. So this is being built open source, and you have the contract folder and the counter CLI folder. So we are grabbing this example and we are building on top of this example, right? To just so we don't have to create anything from scratch, and kind of creating a framework so everybody can work in parallel and in synergy, right? So we grabbed these examples and then we started adding the pieces necessary to actually have a UI. So if you see this contract and counter CLI, we have these two folders, counter CLI. The only difference in counter CLI right now is that we have this contract controller. So the API file are the functions for using within the CLI or a TUI. And the contract controller, it's a class built specifically for UI integration. So if you see here, we have some class that we call contract controller. Then we started creating this other folder, Contour UI, where we're going to use that class plus other providers and hooks, plus the wallet widget that we are developing on Mesh. So at the end, you're going to have a starter template that you're going to be able to, just by integrating as a Next.js project, all the contract part, the logic part, and the UI part. And then you just can start working on top of that. And what we want to do also, it's if you have other contracts, you're going to be able to append, right, other contracts. Let's say you have contract for one specific smart contract, you have another contract for another logic. You're going to be able to attach all these contracts here, and within the UI, you're going to be able, for example, for here within components, Midnight, you have the wallet widget. You're going to be able to also append other UIs for other logics. So in this way, it's kind of a Lego, right? Where you are able to connect different pieces and able to build your application by yourself. So yeah, this is something that we are building, and you can find all this repo if you go to our repo under Mesh organization. Let's open. So under Mesh, we are building these two repos. One, it's called the Midnight starter template. So this is the template that I was just talking about, that you can create your project from scratch with all these batteries included from the contract and the UI part. And also we are building this other repo, which is called the Midnight repo. And what we have here inside, it's other examples, the documentation for those examples, and also some packages. So all these things that I just showed you, you're going to be able to actually use it in two ways. One, it's importing the code itself, so you're going to have more flexibility to actually change it. Or if you don't want to change the code, you can actually download this code as npm packages. So you just npm install whatever package and you just plug it into your code and it works. Okay, perfect, guys. So this is it for this session. The next session is gonna be on Friday, and we're gonna keep looking at the code and understanding how this state works, right? So we finished this session by getting this output from the circuits. So in the next session, we're gonna understand what all these outputs means, and for that, we're gonna have to design some graphs so we can understand how the state it's located and stored on the CSwap level, on the Kachina level, on the private state level. So next session is going to be really interesting, and I hope to see you all. So see you next session. Have a good day. Bye bye.